factoring polynomials, more specifically quadratics, we look at standard form, which is ax squared plus or minus bx plus or minus c. When we factor, we're basically looking to see what factors of our leading coefficient and constant create our middle term. So what factors of our leading coefficient which was A, multiplied to our constant C, add or subtract to give us our middle term, which is B. Okay, if I have a positive C, we're going to add our factors, and both of those factors will have the same sign. And whatever the sign of our B or middle term is, that's the sign that both factors get. If C is negative, then instead of adding our factors, we're going to subtract them. And then instead of the same sign, we'll have different signs. And then this will be the term, this will be the sign of the largest factor. So we can use these as guides as we are factoring. Factoring when our A is 1, which in this case it's a 1. If it's not written there, it's understood to be 1. It's just simply easy factoring. Put up our parentheses, and we say, what times what gives us x squared? It's x and x. Then we think, what factors of 30 add, since it's positive, to give us negative 17? Well, it's 15 and 2, and since 17 is negative, both of these are negative. So we get negative 15 and negative 2, and that's factored out. For this next one, we do kind of the same thing. Put up your parentheses. What times what gives us x squared? X. What factors of negative 36, and instead of adding, we're going to subtract our factors. So what factors of 36 subtract to give us 6? This should actually be 5x. So what factors of negative 36 subtract to give us 5? Well, we know that 9 and 4 multiply to give us 36, and 9 minus 4 gives us 5. So then since 5 is positive, we want our largest term to be positive, so 4 will be negative. 9 times the negative 4 gives us negative 36, and 9 minus 4 gives us a positive 5. So we have x plus 9 and x minus 4. Alright, so now let's look and see what happens when A is not 1. Okay, we can use the box method that we use for multiplying binomials. We can do the same thing, just backwards. We're going to draw a box. And the way it works is our first term goes in the first box. Our last term goes in the last box. When I was talking at the beginning, I said the factors of our leading coefficient time our constant. So what we need to do is we need to multiply our leading coefficient, which is 3, to our constant, which is positive 2. So 3 times 2 is 6, and we want to add our factors to get negative 5. So the factors of 6 that add to give us 5 are 3 and 2, and since 5 is negative, both of them will be negative. So we get negative 3x, and we get a negative 2x. So then what we do now is we need to get our greatest common factors from our rows and our columns. So the greatest common factor in our first column is x. the greatest common factor in our second column is just 1. And what we do is we follow the leader. If our first term in that row or column is negative, then we need to pull a negative out as well. In our first row, we have a 3 and an x as our greatest common factor. And then in our second row, we have a -2. Again, follow the leader. Then you can always go back and double check and make sure that what you pulled out for your GCF fits our problem. 3x times x is 3x squared. 3x and -1 is -3x. -2 and x is -2x. And -2 and -1 is 2. So we did it correctly. So our factors for this quadratic are x minus 1 and 3x minus 2. Okay, so let's look at another one. Again, we'll draw our box out. First term in the first box, last term in the last box. And again, we need to find factors of our leading coefficient times our constant, which is -90. So what factors of -90 subtract to give us 43? Well, 45 times 2 gives us 90, and 45 minus 2 gives us 43. So 45 and 2. Our largest term gets the sign of our middle term, so 45 will be positive and 2 will be negative. So we get a -2 in, and we get a positive 45 in. Then we do the same thing we did before. Our GCF in the first column is 9x. And I accidentally wrote in. These should be x's as well. And then our GCF in our second column is -2. Again, follow the leader. This one's negative, so we pull out a negative with it. Our GCF in our first row is just x. And our GCF in our second row is 5. We can always go back and double check. X times 9x is 9x squared. X times -2 is -2x. 9x times 5 is 45x. And 5 times -2 is -10. So our factors are 9x minus 2 and x plus 5. Okay, one more like this. Always check and make sure you have a GCF in your quadratic function before you start factoring out. And in this case, we do. 4 goes into 16, -16, and 4. So what we're going to do is we're going to divide each term by 4. We want to get out that GCF to make it smaller and easier. We didn't have a GCF in any of the ones above. They were already in simplest form. So we're going to factor out of 4s. 16 divided by 4 is 4x squared. -16 divided by 4 is -4, then our x, and 4 divided by 4 is 1. That's only one additional step you have to do. The rest follows just like what we've been doing. So we'll do our box again since a is not 1. First term in the first box, last term in the last box. And again, find the factors of your leading coefficient and constant multiply together, which is 4. So what factors of 4 add to give us -4? Well, 2 plus 2 is 4, and 2 times 2 give a 4. So since our middle term is negative, we want these two terms to be negative as well. So we get -2x and -2x. And then pull out your GCFs. GCF in the first column is 2x. GCF in the second column is -1. Again, follow the leader. GCF in our first row is 2x, and GCF in our second row is -1. And again, go back and double check. 2x times 2x is 4x squared. 2x and -1 is -2x. -1 and 2x is -2x. -1 times -1 gives you a +1. So our factors are 2x minus 1 and 2x minus 1. Since these factors are the same, we can also write this as 2x minus 1 squared. Alright, So getting into some other types of factoring problems. This one is a cubic function. It's a polynomial. It's more than a trinomial, so we've got 4 terms. What we can do is we can factor it by grouping. And there's 2 different ways to do this. One, simply group our terms in groups of 2s. And then pull out your GCFs from those terms. My GCF in 12x cubed and 4x squared. 4 goes into 12 and 4, so I can factor that out. And x squared is an x cubed and x squared, so I can factor out an x squared. So 12 divided by 4 is 3. X cubed divided by x squared is x. 4 divided by 4 is 1. And x squared divided by x squared is 1. Do the same thing with the next one. Well, there is no GCF, so we can leave it as 3x plus 1. When you do this, you should get 2 terms that are the same that you can factor out. So we're going to pull these 2 terms out. We get 3x plus 1. And what we're left with is 4x squared and a positive 1. The other way of doing this is using the box method. Fill in what you have. First term in the first box, just like when we did the above factoring, last term in the last box, and then your 2 middle terms, doesn't matter which position you put them in. So I could put 4x squared here or down here, it doesn't matter, and then my 3x. Then get your GCFs out like we did before. GCF in the first column is 3x. GCF in the second column is just 1. GCF in the first row is 4x squared. GCF in the second row is 1. And again, you should get 3x plus 1 and 4x squared plus 1. So either way you do it, you should get the same answer. One more of those. Always check and make sure to see if you have a GCF in all 4 terms. None of these we do, so we can just simply keep going. We'll do it by grouping. GCF in the first 2 are 5. 5 goes into 5 and 10, and also x squared. So we're left with just 1x and a negative 5 goes into 10 2 times. In the second pair, we have 3 for our GCF, so we get x minus 2 again. You should still have a factor that you can factor out and pull out, and you get x minus 2, and we're left with 5x squared plus 3. Again, you can always use the box method for this as well. First term in the first box, last term in the last box, and put the other ones in the other boxes. Again, it doesn't matter which order. So GCF of the first column is x. GCF of the second column is negative 2. Remember, follow the leader. GCF in the first row is 5x squared. GCF in the second row is 3. And again, you should get the same answer that we did before. Last kinds of problem I want to discuss is perfect square binomials. Set it up like we did when we had a is 1. Just put your 2 sets of parentheses up. And then all you do, every single piece in here is a perfect square. So the square root of 16 is 4. Square root of n squared is n. Square root of 9 is 3. And we make 1 positive and 1 negative. We call these conjugates, because what's going to happen is when you multiply the 4n times negative 3, you get a negative 12n, and 3 times 4n gives you a positive 12n, and the middle terms cancel out, so all you're left with is your 16n squared and your negative 9. Same thing happens with this one. Square root of 9 is 3. Square root of x squared is x. Square root of 1 is 1. 1's positive and 1's negative. Always when you're factoring, make sure there's not a GCF before you start doing something. Always go through, look and see if there's greatest common factor in all of your terms. If there is, factor it out first. that'll make factoring a lot easier.